Okay, so in triangle ABC, AB is 86, AC is 97. A circle with center A and radius AB intersects BC at B and X. BX and CX have integer lengths. What is BC? The first thing to notice is that this looks like a geometry problem, but it's actually more of a number theory problem, which is a very interesting thing to observe. And specifically, you can see that by noting the condition that bx and cx have to be integers. That's a very interesting condition for a geometry problem. And as we'll see, more of the core argument is in the number theory. Now, by a fairly well-known theorem, the power of a point theorem, stating that this distance to this for an external point, a point outside a circle, we have the distance to the circle times the distance to the circle plus the distance to the second intersection of the circle, if it's a secant line, is equal for any lines drawn through the circle. And in this case, we have two lines, which essentially gives us the following equation. So A times B is equal to 11 times 11 plus 2 times 86. So 11 is this distance, and then the total distance is 11 plus 86 times 2, since it intersects the circle at the edge of the diameter. After doing a bit of factoring, you can find that, actually first computation and then factoring, 86 times 2, this is 172, plus 11, 183. And if you factor this, this comes out to 61 times 3. 61 is a prime. Now, how can we find integer a and b so that this is satisfied? Now, the first thing to be very careful of is we want BC, which is a length of a triangle, and we have 86, 97. But the third triangle length, call it C, has to be less than the sum of the other two, and also this pair needs to be greater than 97, and so on. Although this case is trivially true, since C is positive. And in general, for a triangle, this is the case, right? For any pair, the sum of them has to be greater than the third. So we need to be careful that the factorization of AB that we pick satisfies this condition. Now, since A and B are integers, they're just some combination of prime numbers that gets us to here. And just a bit of trial and error gives you A equals 33 and B equals 61. And as you can see, this does satisfy the triangle inequality, because if just trying every pair would work. Now, if you had BC equals 11 somehow, then that wouldn't quite work, namely because 86 plus 11 is not greater than 97. So you need to be really careful to make sure that you satisfy the triangle inequality. So our answer is B, 61, which corresponds to